You missed. Oh, is it 1 through 8?
No, I pulled up the 10th grade one. So.
Oh, so all we have, so we can watch that video and you can.
Okay, I'll show you a video at the end here, and we'll just get this over, and we'll watch an orbital mechanic video. That'll be fun. I gave you 1 through what?
12.
I gave you 1 through 6. Remember, this is the 10th grade one. So I gave you 1 through 16. Any questions?
Yeah. No, there's no question. Coordinate geometry would just be easier geometry.
Coordinate geometry is we're going to take the shape, we're going to put it on the Cartesian plane, and then we're going to be able to prove things or be able to calculate things by doing that.
Yeah, that's what I figured. I mean, it's.
The hardest thing is knowing where to place it to make your life easy. And we will spend some time talking about that. Not today, obviously. All right. Anna, question?
Wait. If you...
12 or 14.
All right, let's take a look at 12 and 14.
make my sausage.
12 is a basketball court, right? So I'm not going to attempt to draw the basketball court, but you have basically the key and
Wait, that hoop is way too
is it
big.
called the lane or something like that? Is this whole thing called the lane?
It's called the paint.
Well, the whole thing is called the paint, right? But isn't this part called the key?
Yeah. The top of the key is the 3-point line.
Well, maybe the whole thing, keyhole is what they're really referring to, because it kind of looks sort of like a keyhole. But this part right here, isn't this called the lane?
It is. Maybe, yeah.
You're the basketball player.
Yeah, I'd
I
say
played it in middle school, and I can't tell you anything about
I just
basketball.
call it the paint.
Okay.
I don't call it the lane.
All right, so you got this piece and this piece. This piece is a,
Rectangle.
and this piece is a half circle, right? So formula for this?
Plus, that guy has a really bad job.
15 c times r squared divided by 2 plus length times width.
No.
You're making it way too complicated. Formula for this, she said it's a rectangle and a semicircle.
Yeah.
So
Half
formula for the
circle.
semicircle.
Pi d over
half
2.
the square.
No.
All right, pi r squared over 2 plus.
Okay, hold on. So we got pi r squared over
I
2.
literally just said that.
No, you said
I
something.
did.
You threw a C in there.
You're like C.
I said pi r.
You said
times
C
r
equals.
squared
We can play the video. Go ahead. Yeah, this part. No, just this part right here. You're overthinking this. Okay. Plus base times height, right? Okay, now look at the picture. Tell me what we know.
The base is 15 and the height is 12.
That guy.
I'm assuming she's right. You guys got to correct me if she's not.
Yeah, she is.
He's correct. Maybe.
Or there's nothing here, right?
Yeah.
But look at the rest of the picture.
Oh, do you minus that?
Look at this. Is there any number listed on your picture?
Yes, there's 12 and 15.
Therefore, we need the radius. So 6. Okay. So pi 36 pi over, well, that's 18. So we got what? 18 pi plus whatever that mess is multiplied together. Now, do they want to give you leave in terms of pi, or do they want? No, they would say use 3.14. So grab your calculators, whatever that is. So 18 pi plus, that's what, 150 and 30, so 180. Yes?
Was this 12?
That was
Or is
12.
this- Okay. 14 was annoying, but I figured it out. That was the hardest one.
1 can of pumpkin pie mix will make a pie of diameter 8. If 2 cans, 1 can, if 2 cans of pie mix are used to make a larger pie of the same thickness, find the diameter. You would assume, therefore, it should have a diameter of 16, right? Because
No.
you think you could double it?
No.
Well, you would. I'm saying you
Because
would
could take
assume.
concentric circles.
Right. I'm saying, wouldn't it make it if you don't think the problem through carefully, you would make the assumption, well, it's got to be
Wait.
16.
Sir,
What?
number 12 does say use 3.1.
No, I agree. That's what I'm saying. Grab your calculators now. And
Oh, okay.
did you get an answer?
I have my calculator now.
All right.
Mike, I fixed the calculator battery.
I just didn't really want to do it because I did it last night.
All right, I'm gonna quickly do.
Well, I have the answer in the book. I just want to make sure that we did it
All
right.
right, so
18 pi plus 15 times 12, 10 times 12, or
15 times.
15 times 10 is 150. 2 times 15 is 30, so 180.
wait, what? What?
Yeah.
18 times pi times 15.
No. Where are you seeing 18 times 5 times 15?
I
We were
don't
talking
know.
about what that was, not the 18 pi. I can tell you about, well, that's 3 times 18 is 54, and we said that was 180, so about 230. I'm guessing 230.
238.
I got
36.
236.
Oh, like I said, I was guessing it's 230.
It's I got 230.
Okay, book says 237. Is that what it rounds to?
Yeah, that's rounding.
Okay. All right, anything else?
Nope.
All right,
It did say find to the nearest square foot, so.
yeah, so round to the nearest whole number, right.
Whole number.
One side of the rectangle.
Well,
Nearest square foot. Oh, by the way, I looked at the practice, because I need to get ready for next week. I was looking at the practice test that the company that makes the SAT, it's called the College Board. That's the name of the company. I looked at the practice test that they put out for the math part of what you will take for PSAT. It's simple. I mean, it's like, there's not much geometry on it. There better be geometry, I'll be disappointed, right? But when I look at the test, it's everything I looked at was like, everything on the practice test was like 100% algebra 1. So, and it was easy algebra 1 too. None of it was there was a couple of them that were challenging, but it looked like you guys are going to kill that PSAT test. All right. I'm going to not do this super quick, but quickly enough.
The heck?
The algebra review is just getting you used to throwing in a bunch of ugly numbers into an expression to evaluate it.
On the 27th, we don't have school.
Something.
Don't, this is not your calendar. 20 of April, yes. Whatever that Monday is. I thought it was 26th.
Yeah.
On the
I'm looking at
26th?
May.
Oh, May?
Yeah, I'm looking at May.
We will have the last week of school will be finals, so we'll do Monday through Thursday or Monday through Wednesday, whatever we did at Christmas time. You'll have that, Friday is definitely, unless you have to have a makeup, that'll be off. So.
Right. I'm gonna go home and eat cheese whiz forever.
It's a classic line from a movie called The Blues Brothers that has cheese in it. Yes,
What's the homework?
all of it.
So just 1 through 8.
One
Well,
through
what's
8.
the page?
Keep turning until you get to algebra
451.
review.
451?
Yes.
Okay.
All right, I'm going to skip this one because that's ridiculously easy. Let's go to the more challenging one. All right, you guys remember how to square fractions?
I think so.
McKinley, how do we square a fraction?
Square fraction. You just multiply it by 5/4 again.
Okay, so what's the answer here when you throw that in for R?
That'd be 25, 8, 24?
25 over 20.
25
What?
over 16. 16, sorry.
Okay.
Well, I thought it was 4.
Now, the instructions tonight for homework does not say leave it in terms of pi. When I look at all my answers, they want you to leave all the answers in terms of pi.
Right.
So that is literally the answer.
Oh, there's
Okay.
only
Well, actually, the answer is
No, this is the exact answer. If you want to say the approximate answer, then you multiply by 3.14.
no. I mean rounded.
Right, that would be called the approximate answer, but this is what we call the exact answer. All right, so we go on squaring fractions. You'll have to do that a couple times.
Yeah, I'm good.
All right, the other thing that you will have to do is kind of where you got some things just kind of floating around that you got to mix, match, push together, use the commutative property. Ben, what are we doing here?
We are replacing R with 2/3.
Okay.
So now it becomes 2 times pi times 2/3.
Okay,
So we can skip pi and we can multiply 2 times 2/3, and then we get 4/3. The correct answer is pi
we leave pi always at the last.
4 over 3 times 5.
Okay, so that's leaving it in terms of pi then. Okay, questions on that? You'll see this a couple times tonight for homework as well too. Keely, yes?
Yeah, I got it.
Okay.
Looking at it.
The last one is the much more complicated one. We got a mixture of fractions and radical operations. And they'll all be square roots, no cube roots here.
Doesn't the radical operation just cancel out?
Boy, yes, it will. Very good.
And then because of that, you just get a.
But you got to be careful, right? Yes, it will get rid of the square root, but it also has to apply to the 5/4. So when we throw that in there, right, when we throw the values in, inside the parentheses is this whole ugly, messy 5/4 root 2. So not only does the square root of 2 get squared, but the 5/4 get squared. So you're combining two things. So square 5/4,
That's 25, 8, 16,
square the square root of 2.
4.
Mm-mm.
Sorry. No, square root of 2. That's just 2, isn't it?
Mhm. Yes.
And then
So that would be 25 over 16 times 2.
okay. And then that gets you a number bigger than 25
Yes.
over 16.
Well, you could also reduce right there if you wanted to.
So it'd be just 1/8.
Yeah, but you got to do the whole thing.
It'd just be 1/8.
Yeah, but what happened to the 25?
Oh, you can't reduce 25.
You're right, so it's still there
Yeah, it's still there. So it's just 25 over 8
with a pi.
with the pi.
Okay.
But do I really need the pi? I mean, I might eat the
Who
pi.
doesn't need pi?
Me.
I don't need it, but I
I'm not.
want
It's the
it.
same people that don't like pizza, right? I don't understand you people.
Well, I don't like pizza, so what's wrong with that?
All right. I will allow. Who wants to pick? I will allow you to pick one from page 451, and we will do it together. So choose wisely. What do you want? I'll just say this. Everyone in my 10th grade class all thought that number 7 was the hardest one. It's the easiest one.
Okay.
And they're like, I don't even want to try it. It looks too hard. And I was like, just do it. You'll find out it's actually really easy.
Yeah, that don't look that hard.
They were afraid of it. And then I did it.
That last part just cancels out for itself.
No, nothing cancels there.
What do you?
Let's see. These all.
But you can. It's addition.
You can pick, Ben. What do you want?
I don't want to remember responsibility.
And you can pick
okay,
7 if you still think it's hard. But I'm just going to say 7 ends up being pretty easy.
Let's do.
What? That is so weird. How does that work?
Let's try number 3.
Okay, number 3. Does anybody recognize that formula? 1/3 pi r squared h. Did anybody remember that from
Yes.
2 years ago?
That's
It's
2 years ago.
Well, it's
it's
divided
the
by
cylinder.
It's over there somewhere.
It's the volume of a cylinder.
Well, divided by 3. Well, 1/3 times 1/3 just means divided by 3. So therefore, it's a volume. We take the radius times the height. Therefore, it is a cone.
Cone. Remember that video I showed you? The guy, he takes the cone and he fills it full of liquid and he fills the cylinder 3 times. This is the volume of the cone. Okay. This is a formula we'll use next chapter. But for this one, on what are we given for values here? R equals.
So R equals 2√6 and H equals 4.
Okay, so tell me what to write.
All right. So first, you're gonna write out the. We're gonna replace the variables with the
Tell me what
numbers.
to write.
So 1/3 pi times.
Parentheses.
Yes, parentheses. That's a very specific for it. I'm trying to look at the number here. 2√6 squared.
Okay. Times.
Times 4.
Okay. All right, now everybody's got to pay attention. Some kids will make a mistake here.
Oh, it's just 4 times the 6.
Wow, very, very well done. 4 times 6. Do you see it? 2√6, Jack. 2√6 squared would be 4 times,
Or 24.
because a square of a square root cancels each other out, and you're just left with 6. So that would be 4 times 6.
I
You
thought
see?
McKinley was talking about that other 4.
Why did you have me wake up from my experimentation?
Only because I just want to make sure you understood. Okay, so that's 24, right? So you get 1/3 pi with a 24 and another 4 hanging out over here. Anything cancel? I would never do the multiplication until you cancel. Anything cancel?
Yes, we can divide. Yes, we because it's 24 over 1. So that means that. Wait. First, we got to multiply the 4 with the 1.
Before you do that, look to see if anything cancels. And not that you can't do what you just said.
The pi can cancel.
No, pi's got nothing to cancel.
Okay, then the 1 can cancel.
That doesn't
You
get you
can
anywhere.
take 24 divided by 3.
24 divided by 3, which gives you
6.
what?
Six.
What? 8. 8.
And 8 times 4.
Just act like you did that.
6. But a 2.
24.
And don't forget there's a pi there. So 32 pi. There you go.
Which one was that?
That was number 3. I'm going to tell you, you're going to think that number 7 is challenging. It's not that challenging.
What if I don't think it's challenging?
Well, then you are.
Jack did exclaim earlier. He was like, oh! So I think he figured something out.
No. He was looking at next chapter. I
Oh,
think.
he was looking
No,
at
I was looking at decimal approximations for pi.
Oh, you were looking what's above it. Oh,
I
gotcha.
was looking at
Oh, that's cool.
2 divided by the square root of 0.5 times the square root of
I got you.
0.5 times
I
the
got
square root of 5 root of 0.5. Yeah.
And notice all those fancy names next to it.
Yeah.
Sharp said this in the 18th century. Wallace said this in the 17th
How did they
century.
even figure that
Vieta
out?
said in the 16th century.
I don't know how they figured that out.
They're smart.
Genius.
Okay, let's see.
It didn't really. 3 was my least approximate.
So,
When you hear on the news that somebody figured out a longer approximation of pi, they're using there are better algorithms than this, but this is how they program the computer to get that decimal approximation. Is they use some technique like what's shown there on 451 to give you a better approximation. I forget what the latest one is, but it's billions upon billions of decimals of pi that have been calculated.
Did we do evaluating formulas?
We did. That was the last algebra review that we did.
oh wow, this is a.
Why aren't we doing this algebra review right before the next one?
We are.
Where is it?
If you look at the start of the index, it'll tell you which chapters have algebra reviews.
Oh, found it. That's it's like hidden.
Is there one in 12?
Probably. I don't know. I didn't look. Evaluating expressions? No.
That's what we're doing right now.
If there's 2 pi's in one problem, can I cancel them out? Or
Depends if you're dividing or you're multiplying them. If you're multiplying them, no. If you're dividing them, yes.
if I'm adding them
No.
now?
But think about it. If pi was a variable, if instead of saying 2 pi, I said 2x, and you're doing 2 pi plus 3 pi, well, that would be 2x plus 3x, which would be,
x pi squared. I mean x squared. No,
what's
that's
2x plus 3x?
6x.
2x plus 3x.
Oh, 5x.
So 2 pi plus 3 pi would be,
5 pi.
yeah, that's how you handle that.
That's good.
My calculator is really annoying because it never gives me in terms of pi.
Well, why don't you turn it 2 in terms of
Gosh, I don't know if you can.
No, I don't think you can. I've looked at the modes. I mean, I could
Um,
technically put it on
that's a good
classic.
question. That's a good
to
question.
the internet?
To the internet. Let's see.
Whoa. Oh, no, thank you.
All right, Madison, I know you're not live here, but if you have any questions there, this one's a pretty simple one. But if you do have any questions, go ahead and shoot me a chat or an email. We're going to stop it right there.